Hello everybody, welcome to this edition of the Institute, in which we're going to do some demonstrations dealing with thermal expansion and contraction. So what I have here is I already have a Bunsen burner going. You might not be able to see it real well in the video, but it is, and so I have goggled up to make sure that I am nice and safe. I'm actually going to take off my ID so that that doesn't potentially get in the way. I've got a tie chain on here, so that should protect my tie. So the first one I'm going to do is kind of a trick one. What I have is I have this little piece, and it's got a piece of metal on here. And so as I look at this piece of metal, the idea is, what do you think would happen when I put this metal into this flame? So if I think of taking this piece of metal and putting it into the flame, most people think that, oh well, it's going to soften the metal and it's going to do something to it. So I'm going to start this off. If I take this piece of metal and I put it into the flame, I want you to think about what you think is going to happen to it. Okay, so bringing it down to the flame and putting it in the flame. There we go. So the question is that what you expected? Did you expect that this would do this result? So it bent down as we were kind of dealing with this. So I brought it into the flame and it bent down. So one of my questions is, how do I take this and I straighten it back out? Now, one instinct is I would just flip this over and put it back into the flame. And so as I do that, and I put it into the flame, I want you to kind of see what exactly is happening. So I'm going to try to move over to the side so you can kind of hopefully see this. So now I have this in the flame. I want you to kind of watch the end of that piece. Does it seem to be bending to go down? And if you actually watch the very end of this, what I can actually see is this material has actually, it seems to be bending even more. So it seems to be even more bent than it was before. That doesn't seem like that makes any sense. So how do I get it to bend down when I bring it here, but bend up when I'm trying to straighten it back out? Well, here's one of the things I'm going to do. I'm going to slide this over so you can see my sink over here. And so now what I'm going to do is I'm going to bring it over to the sink. And I want you to kind of see what exactly is going on if I put it into the water of the sink. So now I still have it bent like this. What I'm going to do is I'm going to take this hot piece of material and put it into the sink. So I have some water running now here. And I bring it into the water. So I brought it into the stream of water. You may have seen a little bit of steam come off of there. And sure enough, it is straightened back out. So the idea, if I bring this over and I put it back into the flame, one of the things you'll notice is it'll start to bend downward again. And actually, you can't see it from where you are, but some of that water is evaporating off of there, so the water is going away. But it has bent down again, but by putting it into the stream of water, I can actually straighten it back out. So, why? Why does that work? Why does that do what you just demonstrated, or what I've just demonstrated, where I put it into the flame, it bends. When I try to flip it over and get it to bend, it seems to always want to bend one particular direction. So it doesn't matter which way I put it. If I put it in the flame like this, it's bending upward. If I put it in the flame upside down, it bends downward. So it actually has like a preferential direction, a direction it wants to bend. And by putting it into the water, by cooling it down, that's when we get that to happen. Now, I kind of tricked you a little bit because this just looked like a regular piece of metal, but I'm going to bring in a different one that also does the exact same thing. So when I put this one into the flame, it bends. And if I flip it over, I can see that it's actually bending upward. If I put this into the water, it'll actually straighten out. But I don't know if you'll be able to see this in the video. Here's kind of a difference. There's one side of the material. Here is the other side of the material. Can you kind of notice that this side is kind of a silvery color and this one is kind of a golden color? So this and this are actually what we refer to as bimetallic strips. And what that means is that they actually have two pieces of metal that are side by side. And as those two pieces of metal are side by side and I put them into the flame, one of them is going to expand more for a change in temperature than the other one is. You saw this in your notes on thermal expansion. So as one expands more, but it's still attached to this one, it'll actually cause it to bend towards that as it's expanding. So it'll bend toward the material that actually has a larger coefficient, thermal coefficient. So it'll expand more. And then when I cool it back down, it contracts more and it'll actually pull it back so it straightens back out. So this has been a little bit of an edition of the Hinstitute. I hope you've enjoyed.